All right, so just moving along from that. So again, the idea when it's a perfect square is that, once you get it into factored form, then by writing it once with the square, that is your vertex form. Because remember, vertex form has something squared. Whoops, sorry, you can't see that. While factored form has the double set of parentheses. So I did B. I'd suggest you guys try D now. And then I'm going to move on. I'll do A and I'll let you do C. So here, when I move to A, what I want to know is what number was it that I cut in half, and then I had this number and I squared it and I got 25. So the number that I can square and get 25 is 5. So what number did I cut in half to get to 5? Well, that would be a 10. So that's going to make this be a 10x. So again, if you just take this and you want to get it into factored form, and then from factored form we can jump straight into vertex form. I need factors of 25 that get me to 10x, and then I'll be rewriting it. So I'll rewrite it over here. So instead of 10x, we'll have this version of 10x. So x squared plus 5x, a 5x, and a 25. And now I'll just do the GCF on this first set. So what's the GCF here? I'll be taking an x out, and then I'm left with x plus 5. And then I'll need my matching set. I'll need another x plus 5. So what was it that gives, when I take it to x, gives me the 5x, and that'll be a 5. So again, I'll have two sets of matching parentheses. I'll have x plus 5 and another x plus 5. And that's factored form. And if I just write it once with the parentheses squared, then that's vertex form. So you can go back and try C now. All right, let's see. 7, we are factoring completely into an equivalent form. So again, factoring, just remember factoring completely, if you look at your flip book, means I should look for a GCF. After the GCF 2 terms, I should see if there's a difference of squares, and with 3 terms, I should see if I can do the x. Now, just because all these steps are here doesn't mean you're going to do all the steps and factor completely. So the first thing I'm going to do here is look for a GCF. I don't notice something that I can take out of all of them, so I'm going to make my x. And again, draw my loop. I need factors of -10 that get me to this -3. And you can run your factor program or look at your factor page, but the factors of 5 and 2 will get me to this -3. I'll just have to make the 5 negative. So now I'm going to rewrite it. So it's going to be x squared minus 5x plus 2x minus 10. Again, I'm just rewriting this version of -3x with this version, and now I'll group them. And I'm going to look for a GCF. The only thing that I can take out of both of these is an x. So x with what gives you x squared, that's x. X with what gives you 5x, that's 5. And I'll go for my matching set. I need another x minus 5. So what is it with x that gives you 2x? That's the 2. And now we can write our final factors, or our final neighbors that gave us the x squared minus 3x minus 10. So one of them is x plus 2, and the other one is x minus 5. All right, so moving on to B. First thing I'm going to do is look for a GCF, and we were talking about the GCF is, you should look at the smallest number and see if that is the GCF, and 6 is. I can take a 6 out of both of those. So 6 and what gives you x? 6x, I'm sorry, that's an x, and 6 and what gives you 18? That's a 3. And with 2 terms, I would check to see if this is a difference of squares. Do these both have perfect square roots? Which neither of them do. So the GCF is the only step you can do in this problem. All right, let's see, let's go to C. So on C, again, the first thing I'm going to do is look for a GCF. So I would check for 16. 16 doesn't go to 81, and any parts of 16, there is no GCF for this one. So I'm going to go, since it's 2 terms, straight to the difference of squares. So look for this one's square root. It's 9 and x, and the square root of 16 is 4. Sorry, you couldn't see that. And now I can make my 2 sets of parentheses, 9x plus 4 and 9x minus 4, and you have factored that one. All right, D, what I'm going to look for is a GCF. I don't see a number that I can take out of all of those. The biggest number that I could possibly take out is this 2, and I can't take an x out. So with 3 terms, I'm going to make my x. So factors of 24 that get me to 11. Again, I'd run my factor program or look on my factor page, and I'm going to see that I got 8 and 3. And now I can rewrite it. So 11x will be replaced by that. And now that we got those 4 terms, we can group them up and look for a GCF here. So I can take a 2 out of both of these, and I can take an x out. So 2x and x give you the 2x squared. 2x and 4 give you the 8x. And then I'm going to make my matching set. So what is it that goes with the x to give you 3x, or what is it that goes with 4 to give you 12? That's a 3. And again, now you've got your 2 final neighbors, or 2 sets of factors. One of them is the 2x plus 3, and the other one is the x plus 4. All right, so letter E. So here when I look for a GCF, again, what I would look for is the smallest number, which is 4, and I can take a 4 out of all of these. And I also noticed I can take 2 x's out of all of them. So 4x squared, and what gives you 4x to the 4th? Well, I just need x squared. And 4x squared, and what gives you 8x cubed? Well, 4 and 2 give you the 8, and x squared, I need another x to get to x cubed. And then 4 and what gives you 4? A 1, and x squared to x squared, that's still just 1. So now what I'm going to do is, with the 3 terms that are left, I'm going to try to factor it. So I need factors of 1. They get you to this -2. And the only factors of 1 are 1 and 1. So how do I get to -2 here? I would make these both negative. So when I multiply these, I get the 1x squared. And when I add them, I get the -2x. So now I can rewrite it. But instead of this -2x, I'll use this -2x. So x squared minus 1x minus 1x plus 1. And again, I'm just factoring this. I'm going to group them up and look for a GCF here. So I notice out of both of these, I can take an x out. X and x is the x squared. X with the 1 is 1x. Get my matching set. So what with x gives you -1x, I would need a -1 here. So my final factors or neighbors are x minus 1 and another x minus 1. And then hopefully you don't forget about that GCF that we took out, because all 3 of these neighbors would have to meet to give you the original problem that we started with. All right, F. Look for a GCF. I don't see anything here. So with 3 terms, I'm going to go to my x. So I need factors of -18. That gets you to -7. And so those factors are going to be a 9 and 2, and I'll want to make the 9 negative. So now I'm going to rewrite it, but -7x will look like this. And again, it doesn't matter if you put the 2x or this first. Your work will look a little bit different, but we'd still get the same answer in the end. So now I can pair them up and look for a GCF here. So again, the number that I should be looking for is the smallest number. And if that's not the GCF, then the GCF would be smaller than 3. Whoops. So I can take a 3 and an x out of both of those. So 3x and an x give you 3x squared. 3x and a 3 give you 9x. So we'll go for our matching set. So what with x gives you 2x, that's a 2. And now we got our final neighbors or factors. 3x plus 2, this set on the top, and x minus 3 for the bottom. All right, so the idea here is this is actually really similar, problem 8, to what we did here, okay? When we got this 36 in there, we were able to factor it so that we got identical parentheses. And once we got those identical parentheses, it became one set of parentheses squared. So that's what we're going to do here. We're going to find out what A is, whether you look at A like this or A like this. So I'm just going to factor this, because when you see those double parentheses, that's factored form. So I need factors of 100. That'll get me to -20. So those sides are 10 and 10, and they're going to both have to be negative to get to the -20. So then you can rewrite it. So x squared minus 10x minus 10x plus 100. And then we can group them up because we got 4 of them. And what's my GCF here? Not a number, just an x. So x with x give you x squared. X with 10 gives you 10x. And then you can go to your matching set. And what with x gives you -10x? Well, I would need a -10 here. Or remember, you could always take 100 divided by -10 to find out what that number is. So when I'm done, I'll have x minus 10 and x minus 10. Or I could write it once. sorry you couldn't see that, with the squared. In any situation, minus a, minus a, minus a, minus 10, a is this 10. Okay, so they have us do a lot of the same stuff on the test. They kind of just phrase things a little differently. All right, so which of these are a perfect square trinomial? So again, a perfect square trinomial means that if you did factor it, you would get, identical parentheses, all right? And if you made your x, if you haven't noticed yet, the side numbers were always the same, okay? So the other way I can check is if it's a perfect square trinomial, then if I look at it in vertex form, I should just have one set of parentheses squared. So I'm just going to see if I factor these, do I get identical parentheses? So factors of 9, they get me to 6x. So this is one way you can do it. So those would be 3 and 3. And then you can rewrite it. So again, 6x is just replaced by this. So this is one way. I'm going to show you a different way on the other problem. And then I can group them up. And my GCF is x, so I can take out x plus 3. And then I have to have my matching set of x plus 3. So what is it with x gives me 3x, or what with 3 gives me 9? That's another 3. And sure enough, I get 2 identical parentheses. Since they are identical, this is called a perfect square. So that's one way. See if you get identical parentheses. The other one is basically do what we did here. If I take this number, cut it in half, and do the math, I get 36. So I just want to know, if I take this number, cut it in half, and then square it, do I get this number? And I do. -4 squared, remember you would want to type it that, in parentheses on your calculator, is 16. So this is, I'm going to circle it, and this is. So I'm going to let you decide how you want to do C. Do you want to factor it and see if you get identical parentheses, or take this number, cut it in half, square it, and do you get that number? And if it is, circle it. If it's not, then just, you could say it's not. All right, the rest of these problems are completing the square. So remember, completing the square, some things that we wrote, is you got to separate the x's out, and it's got to be just x squared. So when we wrote this one and it had to be x squared, and we separated these x's out, we took a 3 out. So this one is good to go. It's x squared. I am going to add the opposite here, and I'm going to group these x's together. And you guys did really well with this. And if you really want to think of it as a square, maybe not put a blank, put a square in there. Maybe that will help you remember that. Anyway, I'm going to take this number. It is -2, not 2. I'm going to cut it in half, and that's -1. And then -1 squared is 1. So 1's going here, and that's all it's worth. There's not a number over here that's changing the value of this. This is x squared, this is -2x, this is 1. So if I add 1, I have to subtract 1. So then from there, we would always focus on the outside. Maybe here you want to go through and add the opposite, because then you'll see that outside the parentheses, it's really -8 plus -1, and you'll get -9. And then in parentheses with x plus will be the number that's in front of the squared, just like we'll have our squared here. And now this is in vertex form because we completed the square. All right, so D is just like this. So I'm going to let you guys do D, okay? And then B, I'll do C, and I'm going to let you guys do B. All right, so let's switch over here and do C.